Right, this is the video that goes along with the motion notes that we have taken. So, first off, we just want to refresh our memories of what is kinematics. Kinematics is the science of describing the motion of objects using words, diagrams, numbers, graphs, and equations. We're going to be using all of those things to talk about motion. To get us started, we want to think about whenever we're working with word problems or thinking about motion, we always want to think about position and reference points. So the position is the description of where the object actually is. So the object is at the 2-meter line. And we can say that they're at the 2-meter line or they're 2 meters away from our reference point. The reference point is a fixed location where everything else is going to be compared to. The reason a reference point is so important is because when we start to get into displacement, where you are in relation to a starting point is going to be crucial to determine if it's a positive or a negative number. So that leads us into scalar versus vector. Scalar are units that describe only the magnitude or how much of something there is. So that only provides a numerical value. Now this doesn't mean that it doesn't have units. Like for instance over here, the hiker is walking 3 miles per hour. The mile per hour is the unit, but it's not telling us anything about direction related to where the person is walking. So scalar just gives us value. Vector gives us value and direction. The hiker is walking 3 miles per hour to the south. Because it has a direction related to it, we call these vector units. For what we're going to be talking about with the beginning parts of motion, whether or not it's scalar or vector is going to make a big difference into how we solve these different problems. So take a second, you can go ahead and pause it and look at what you think these next three are. Okay, so you should have had that the 5 meters is scalar because there's no direction, 30 meters per second east is vector, 5 kilometers north is vector, and 20 degrees is scalar. Now let's get into distance versus displacement. Distance is the total amount of ground that is covered by an object that is moving. It is a scalar quantity. We do not care about direction at all when we talk about distance. So if I was talking about this, if this was a person who went for a hike, they started off here and then they walked we'll say 3 kilometers and came out on the other side of the trail. So their total distance traveled is 3 kilometers. Displacement relates to how far away is that person from where they started. So that might be something like just 1 kilometer away. Maybe they parked in the parking lot here and popped out at the other side of the parking lot. Their displacement is going to be a much smaller value because direction matters. We're just doing a straight line from the start position to where they ended up. Now, because it is vector, that also means that we pay attention to direction. So if I wanted to say this as a vector quantity, I would say the person ended up 1 kilometer southeast of their starting point. So it's not only how far away they are from the starting point, but also what direction they are in relation to the starting point. So let's do a little bit of practice here with calculating distance. To calculate distance, it's probably the easiest. All we have to do is just add all of the distances covered total together and get that total. Direction doesn't matter. So because direction doesn't matter and because we're just adding those distances together, the distance cannot be a negative number. It will never be a negative number. So in my example here, I have Julie walks 6 meters east, then turns and walks 4 meters west. What was her total distance? Well, she walked 6 to the east, so that's 6 meters, and then turned around and walked another 4. So that's a total of 10 meters for their distance for her, as far as they walked. So again, we're just adding those together. I don't care about the fact that this was east and this was west. Displacement is going to be different because direction does matter. And also, since direction matters, we can also have a negative displacement. Now, when we are given positions, what we are going to do is we are going to use this equation. X, which is overall displacement, equals XF, our final displacement, minus XO, which is our initial displacement. When I say that the displacement can be positive or negative, the value, the sign of our numbers in physics when we're talking about distance and displacement does not mean less than or greater than. What it actually means is direction. So if it's a positive number, that means that is moving to the north and to the east, or up and to the right. It's going to have a positive value, just like on a coordinate plane. When you're doing math, if you have your X and Y axes, when you go up from the zero, the center, 0, 0 on your graph, when you go up, you're in positive numbers, and when you go right, you're in positive numbers. So any direction that is up or right is considered a positive value, whereas if you go down or to the left, it's a negative value. Now again, the negative does not mean that it's a smaller number, it just means that it's in the direction to the left or down from our reference point, from our starting point. So if we go back to our example of Julie walking 6 meters east and then turning and walking 4 meters west, if we want to find the displacement in this case, we have our starting point, which was at 0. So that's going to be my XO, my initial position. I have her ending position is at 2. So that's my final position. So in order to find what the end displacement is going to be, I would have my final, which is 2, minus 0, which gives me x equals negative 2. So again, my XO is my starting position, my XF is the final position, and this works really well when you're on the number line. Now, since we know that it is a positive number, that also means that Julie ended 2 meters to the right of where she started. Okay, let's look at this one. It's a little bit more complicated. Keon walks 2 kilometers east, 8 kilometers west, then 4 kilometers east. Total distance and final displacement. So for distance, we're going to have the 2 plus the 8 plus the 4, which gives us a total of 14 kilometers, which is what he actually moved. He moved 14 kilometers. But to get the final displacement, where did he end up in relation to where he started? My XO is 0, and my XF is negative 2. So I have negative 2 minus 0, which means his final displacement was negative 2 kilometers, or 2 kilometers to the west. You can write it either way. You can either write negative 2 or you can write 2 kilometers west. Either one works in terms of telling the person who's reading it that they are to the west of their starting location. All right, let's compare distance versus displacement values. So, in the situation where an object moves in one direction and one direction only, in the case of A and B here, both the value, the numerical value of both your distance and your displacement are going to be identical. So in this case, person A starts at position 0 and walks to position 7. So that's a total distance of 7. Their XF is 7. Their XO is 0. So that means 7 minus 0. Their displacement is also 7. And since it's in positive direction, it's also a positive number. For person B here, they start at position 12, then they walk back to position 7, so that means they moved a total of 5 meters. So their distance is 5 meters. Their displacement, 12, is the XO, 7 is the XF, so 7 minus 12 gives us negative 5. Again, the negative is telling us that the person moved to the left. Not that they moved a smaller distance, but that they moved to the left. So when you're moving in one direction and one direction only, your distance and your displacement will be the same numerical value. If you move in multiple directions, if you move to the right, to the left, to the right, so you're going back and forth, then you will find that every single time your displacement will be smaller than the total distance that you traveled. So in this case, looking at C, they start at 2, they go up to 10, which is 8 meters, then they go back to 8, which is another 2, and then they go back to 10, which is another 2, so a total of 12 meters. But when I use my equation for displacement, I have 10 minus 2, 10 minus 2, so their displacement is only 8. So if you are moving, if you change direction at all, your displacement will always be smaller than the total distance traveled. All right, last little bit we got here. Let's say you don't have a number line and you need to calculate displacement. Calculating distance is easy. Like we said, you're just going to take all of those values and add them together. Calculating displacement without position, without having a number line to use, can be a lot more, or can seem a lot more complicated. But really, all we're going to do is we're going to pay attention to direction. So if the object is moving west, so we have 202 meters west here, 176 meters east, another 94 meters east, and finally 312 meters west, what that means is I am going to take those numbers and I'm just going to make them a negative. So negative 202, negative 312. So that when I get to this, I will end up with negative 202 plus 176 plus 94 minus 312. So again, I'm just adding the numbers, but because I made the westward values negative, when I add them together, I will get that my displacement is negative 244 meters. Or it means that the jogger ended up 244 meters to the west of where they started running.